awak. Awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih. Hai, Assalamualaikum. Jom kita revise sambil berehat. Sambil berehat pun, kita boleh belajar tahu dengan tengok handphone. Apa tunggu lagi? Jom kita mula. Okay, hi, Assalamualaikum and welcome back to my channel. Jika anda pertama kali hadir ke channel ini, selamat datang saya ucapkan. Tapi jika anda pernah hadir dan kembali semula, tahniah kerana rajin dan sudi kembali. Jadi dalam video kali ini, kita akan discuss beberapa soalan berkaitan dengan subtopik 8.3 iaitu Rotational Dynamics. Okay, but before that, remember, before this, we have learned about linear motion. Okay, and based on the first Newton's law, total force is equal to ma. So when there is a total force in the system and there is an acceleration a, alright, but when the total force is equal to 0, means that the system is in equilibrium. So in the rotational motion, okay, so in rotational motion, so the turning effect, so when an object, for example, let's say we have a pulley, so when the pulley is rotating, so we write as total torque, which is the turning effect, is equal to I, which is the moment of inertia for the pulley, times the angular acceleration. Okay, so kalau nampak dekat sini, bila kita comparekan equation of total force equal to ma dengan equation of total torque is equal to I alpha, so kita nampak macam lebih kurang sama kan dia punya analogi. Okay, so dekat sini kena tahu dulu berkaitan dengan total torque is equal to I alpha, and then remember equation of torque we have learned before, it is equal to RF sin theta, where the value of torque will be maximum when the angle here is equal to 90 degree. So nilai torque pada objek tersebut akan jadi maksimum. Boleh? Jadi sekarang jom kita mula untuk jawab example number 1. Alright, now look at example number 1. Okay, but before that, ignore yang ni lah. Yang O ni typo ni. Okay, so here we have three forces which are F1, F2 and F3 that applied tangentially to a disc with radius 30 cm. So the radius here is 30 cm. So make sure in calculation you change to meter, and the mass of the disc is 5 kg. Alright, so now we want to calculate what is the net torque on the disc. So for question A, we want to find the total torque on the disc. Okay, sebabkan kita ada three forces, means that we have three torques that produce on the disc. Okay, so total torque, okay, at a pivot point of O is equal to torque 1 plus torque 2 plus torque 3. Okay, so sekarang kalau kita ada tiga daya yang kita letakkan pada disc tersebut, kita tak tahu akhirnya disc ini akan berpusing counterclockwise direction ataupun rotating in clockwise direction. Okay, so we need to determine first, okay, what is the direction of torque for each forces, and we need to start with the first force which is F1. Okay, so kalau saya lukis dekat tepi ini, okay, awak tengok betul-betul. Okay, so we start with F1. So this is the pivot point, and then this is R. I label as R, the radius of the disc, and the direction of F1 is directly upward. Okay, and they are 90 degree. So now the direction of torque due to force 1. Okay, kalau kita daripada sini, this is O, pergi sini, naik atas, patah balik ke O, kita nampak the direction is clockwise direction. So in your calculation, when you want to calculate the net torque on the disc, so make sure you substitute the negative sign of torque 1. Alright, so let's write that torque 1 is equal to negative Okay, so formula torque adalah RF sin theta. So it should be RF1 sin 90 degree. That's why kalau you perasan, okay, for torque on the pulley, kita selalu tulis sebagai RF because we cancel sin 90 because it's equal to 1. Okay, and then look at the direction of torque due to the second force. Okay, let's say we have this is the pivot, okay, and we move upward R, and then sambung kepada F2, okay, and the angle between them is 90 degree, and patah balik ke O, so the direction is anti-clockwise, so it should be positive. So torque 2 is positive RF2 sin 90 degree, so it is equal to 1. Okay, and let's proceed to the third one. So for the third force, so this is the pivot point O, and moving upward R, and then F3 to the right, and the angle is 90 degree, and the direction of torque is clockwise direction, and it is negative value. So torque 3 is equal to negative RF3 sin 90 degree. Okay, so now let's substitute in our calculation here. So torque 1 is equal to negative RF1 plus torque 2 RF2 plus torque 3 is negative F3. Okay, so positive negative ni penting. Nanti total torque dia akan jadi salah. Okay, so we substitute here. Okay, kalau nak factorizekan R pun boleh. So dia akan jadi R negative F1 plus F2 minus F3. So substitute R that is given, which is 0.3 meter. Tukar kepada meter. Okay, negative F1 is 2.8 plus F2 7.4 minus F3 11.3. Therefore, you will get the total torque on the disc is equal to negative 6.7 Newton meter. Unit jangan salah. And then look at here that the answer is equal to negative value. Means that the direction of the rotation for the pulley is in clockwise direction. Bila kita kira, okay, total torque kita tahu. Akhirnya, disc ini berpusing in clockwise direction. Okay, so finish question A. And then for B, calculate the magnitude of angular acceleration influenced by the disc. Okay, so we want to find what is the value of alpha. Since the disc will rotate clockwise direction, finally dia akan rotate in clockwise direction, tetapi berapa nilai dia? So we can relate for question B, where total torque is equal to I alpha. Okay, so sebabkan kita dah ada nilai total torque of the disc tadi, so kita boleh masukkan nilai dia lah, iaitu negative 6.7, and it's equal to I. So I kita kena kira dulu half mr squared. Kalau nak kira asing pun boleh. Okay, half, and the mass is 5, and r is 0.3 squared. Make sure in meter. And then I is 0.225 kg meter squared. So kalau kita masukkan dekat sini 0.225 alpha, so alpha you akan dapat nilai negative 29.8 radian per second. Okay, so the magnitude of alpha is equal to 29.8 radian per second squared, but the direction, okay, the direction of the rotation is in clockwise direction. Okay, kalau you dapat torque ini, nilai total torque positive, okay, so means that the rotation is in anti-clockwise direction. Okay, so tadi kita dapat negative, so kita tahu that the direction of the disc is in clockwise direction. Okay, so finish example number 1. So let's proceed to the second example. Okay, example number 2. So here we have a pulley and the radius of the pulley is given 5 centimeter. So let's take out the value and convert to meter. So R is equal to 0.05 meter. Okay, and then object M1 is released from rest and travels 2 meter in 1 second. Okay, so means that this object will moving downward. Okay, and kita tak tahu berapa dia punya acceleration, but it will move in 1 second and it will travel downward equal to negative 2 meter. So I will put negative sign because the direction of the motion is downward. Okay, the pulley rotates without slipping. Determine the moment of inertia of the pulley about the axis of rotation. So this time we want to find what is the value of I for the pulley. Okay, the moment of inertia for the pulley. Okay, so let's try to calculate. But before that, I want to draw, okay, the free body diagram on the pulley and also the free body diagram on the mass. Okay, so now look at here. Okay, since we know already that the motion A for the pulley here is downward. Okay, sebab dia lagi berat kan? So this one should be going upward. Penting you kena tahu direction of A sebab kita nak tulis equation for M1 and M2 dengan betul. And then, how about the pulley? Okay, obviously, when M1 is moving downward and M2 is moving upward, so the pulley will rotate in clockwise direction. Okay, penting sangat ini. So now, I want to draw all the forces on M1 and M2. We start with M2. So we start with M2. Obviously, we're going to have the weight for mass 2. And then, here we have T2. Okay, beza dengan chapter 4, kita assume dia sebagai frictionless pulley. So, tension dekat kedua-dua belah itu kita consider sama, T. Tapi dalam chapter 8, bukan frictionless pulley. Okay, so T2, kita ada nilai T2 dia. And then dekat sini kita akan ada T1. Sebab itu kita label T1 and T2. So, sini kita ada W1. Okay, so remember that the motion of both masses M1 and M2 is linear motion. Okay, kena tahu sini adalah A, bukan angular acceleration. So, objek ini akan bergerak in linear motion sebab dia akan naik ke atas. Objek ini akan bergerak ke bawah. Okay, straightly downward, so dia adalah linear motion. Siapa yang akan rotate? Yang akan mengalami rotational motion hanya pulley yang ini. Okay, so ini saja yang berkaitan dengan angular acceleration. Okay, boleh? Alright, so now let's proceed. Let's draw the free body diagram, okay, for pulley. This is very important. Okay, so let's say here we have a pulley. Okay, so this is the pulley. Okay, so on this side, we're going to have tension which is downward. So T1. Okay, and on this side, okay, we're going to have T2. Okay, direction T1 dan T2 mesti keluar daripada objek. Okay, outward from the body. Ingat ya. Okay, and here we have the radius R. Okay, and this is also R. Okay, so we know already that the rotation of the pulley is in clockwise rotation. Jadi untuk soalan dalam subtopik 8.3, so this is not equilibrium system. Dia bergerak, dia bukan tidak bergerak. So kita tak boleh nak assume clockwise is negative direction, anti-clockwise is positive direction. This time, okay, look at the direction first. So this time, we need to look at the direction of the torque. due to T1 and due to T2. So kalau kita tengok R here, T1 downward, so direction of torque 1 should be in this direction, clockwise, right? And torque 2 obviously anti-clockwise. Okay, so antara torque 1 dan torque 2, which one has the same direction as the angular acceleration here? Okay, the direction of the angular acceleration dekat sini adalah in clockwise direction. So, dia sama dengan direction ini, torque 1. Therefore, in your calculation, the value of torque 1 should be positive value. Walaupun awak kata, tapi dia clockwise, madam. Kenapa dia positif bukan negatif? Okay, because the direction of torque 1 is the same direction as alpha here. Okay, so dia positif lah, dia akan produce positive torque. Okay, dan dia akan menghasilkan angular acceleration for the system. Dia lagi besar. Okay, compared to this one. Okay, so kita akan tolak dengan torque ini. So, it will be negative value. Boleh So, ini yang paling penting yang ramai yang confused dengan equilibrium of rigid body. Okay, so now, if we write the equation of total torque is equal to I alpha, look at here. Alright, so we have two torque here, torque 1 and torque 2. So, siapa yang positif? So, kita dah tahu. Oh, torque 1 tadi same direction, which is clockwise dengan alpha. So, torque 1 should be positive plus negative torque 2. And it is equal to I alpha. Okay, so kita tak ada nilai alpha, kita nak cari nilai, kita nak cari I ini. Ini yang kita nak cari. Kita tak ada nilai alpha. Tapi tak apa, soalan ni agak menarik. And untuk torque 1, okay, if I expand this equation, dia akan jadi RT1 minus RT2 equal to I alpha. So, in this case, kita tak ada lagi T1, kita tak ada T2, kita tak ada I dan kita tak ada alpha. Okay, but always remember the relationship between alpha dengan A. Okay, sebab apa? Sebab mereka ada hubungan yang istimewa. Okay, sentiasa kena ingat where A is equal to R alpha. Sebab kita selalunya akan guna dia punya perhubungan ini. Macam tu So now I will find first what is the equation of T1 and T2. Macam mana saya nak cari? So I will find that equation from linear motion. Okay, so kalau FBD ini tadi adalah rotational motion. Okay, so ini adalah rotational motion. Okay, so kalau saya nak tulis equation untuk linear motion, macam mana? Boleh ke? Boleh. Okay, kita lukislah. Untuk mass 1 and mass 2. Kalau mass 2, so W2 and T2 is upward. Kan? Lepas tu A dia adalah ke atas. Okay, kalau mass 1, so W1, so kita ada T1, okay, but A is downward here. Okay, so kalau kita tulis equation, alright, T1, okay, T1 first. So, dia akan jadi, okay, total Fy, you belajar chapter 4, equal to M1A. Okay, this is linear motion. Alright, so W1 minus T1, bukan T1 minus W1. Okay, because W1 is the same direction with A. Oh, sorry. Okay, since W1 is the same direction with A, okay, so we will write W1 minus T1 equal to M1A. Therefore, T1 is equal to M1G minus M1A. Boleh? Okay. So, untuk yang kedua pula, sebelah ini pun sama. Okay. But this time, T2 is the same direction with A. So, we will write T2. So, total Fy2 equal to M2A. And here we have T2 minus W2 equal to M2A. So, T2 is positive since its direction is the same as the acceleration A. Therefore, T2 is equal to M2A plus M2G. Okay, so now kita ada masalah, kita tak tahu nilai T1 and T2. Since we don't know what is the value of A here, macam mana nak kira A ni? Okay, so baca balik soalan. So here we have the information about the motion of mass 1. Okay, sebab dia kata mass 1 is released from rest and travels 2 meter in 1 second. Okay, so I will find here, okay, let's find A first. Okay, so from linear motion equation, we can use this equation as equal to half U plus VT. Okay, sebab kita tak ada A. Kejap lagi kita nak cari A kan. So, kalau kita nak guna formula Vuat, Sutat, Vuas, semua tu perlu cari A dulu kan. So, sekarang saya akan cari nilai V terlebih dahulu. So, as we substitute negative 2, okay, half and U start from rest, so 0 plus V and the motion is in 1 second. Soalan dah bagi tahu. Therefore, daripada sini kita akan dapat nilai V is equal to negative 1 meter per second. So, kenapa negative? Because the motion for M1 tadi, it's moving downward, so V is negative. Kan? Okay? So, kita boleh teruskan calculation kita. So, kita boleh cari acceleration by using equation Vuat. Okay? So, this one should be negative 1, 0. We want to find A and T is 1. Sorry, this one should be 4. Okay? So, V is equal to 4. 4 meter per second. Sorry. So, masukkan dekat sini 4. Okay. And then, acceleration you akan dapat nilai negative 4. Bukan sebab dia decelerate, tapi sebab direction of the acceleration here is downward direction. Okay, so kena fahamkan. Okay, menarik soalan ni. Jadi bila kita dah dapat A, kita dah boleh dah substitute dalam equation. Kita namakanlah equation kita. Equation 1, equation 2, equation 3. Okay, so now we can substitute the value of A in equation 2 and equation 3. So tak muat dekat situ. So saya akan mula di sini. Saya nak cari T2. Okay, so from equation 2, so let's find the value of T2, which is M2A plus M2G. So M2 kita dah ada tadi, nilai dia adalah 1 kg and A is equal to 4. Okay, 4 meter per second. Alright, plus G is 9.81. Okay, jadi dekat sini penting So, this equation, masa kita tulis equation ini tadi, kita dah consider the direction. So, kita tengok W1 same direction dengan A. So, kita dah tulis mereka sebagai positive value. Okay, so ini pun samalah. T2 minus W2. Kita dah consider dah dia punya direction masa kita tulis equation. Jadi masa you masukkan nilai 4 ini, make sure you substitute the magnitude only. Tak perlu ambil direction. Sebab kita dah consider direction dekat sini tadi. Masa kita tulis equation dengan betul. Okay, sebab kita dah consider direction. Alright, so now T2. Okay, please calculate T2. So you akan dapat 13.81 Newton. Alright. And then T1, okay, so T1 is from equation 3, So T1 is equal to M1 G minus A. So M1 is equal to 3 kg. So kira lah, sama juga A dekat sini, jangan masuk negative 4. So dia adalah 4 sahaja. Kenapa tak masuk negative 4 kan? Sebab dia downward. Ya betul, dia downward. Tapi ingat, kita dah consider direction tadi masa kita tulis equation dekat sini. Kita dah tengok dah. Masa equation T1 ni kita dah tulis betul-betul. W1 same direction dengan A. So kita dah consider dekat sini direction. Sekali saja kita consider direction. Jadi masa substitute dekat sini, tak boleh kalau you nak substitute negative 4. You kata negative tu direction A. Tak boleh. Sebab kita dah consider dekat sini. Okay, sekali sahaja. Alright. So T1 you akan dapat nilai dia 17.43 Newton. Okay. So sekarang kita dah dapat dah nilai T1 and T2. So we can proceed to the equation number 1. Kita boleh masukkan dalam equation number 1 kita tadi. Okay, so now based on this equation, look at here. So we have R, okay, T1 minus T2. Okay, so I kita nak cari. Okay, so I kita nak cari. And alpha, kita tak ada nilai alpha, kita hanya ada nilai A. Alright, so now let's substitute the value of T1 and T2 in equation 1. So we have R, so kita factorizekan T1 minus T2 equal to I alpha. So now look at here, we don't have value of alpha, but we can change this equation. Okay, alpha is equal to, ingat lagi tak equation ini tadi? A is equal to R alpha, therefore alpha is equal to A over R. So we can substitute here A over R. Okay, therefore we can find the moment of inertia for the pulley. Okay, and it is equal to R squared T1 minus T2 over A. Okay, so R soalan dah bagi tadi nilainya adalah 0.05 meter. Jangan lupa squared. T1 kita dah kira 17.43 minus 13.8. Alright, and acceleration here is equal to 4 meter per second squared. Okay, jangan masukkan negatif pula, nanti jawapan I kita negatif. Okay, moment of inertia mana ada negatif. Okay, and then use your calculator to calculate I. So finally you will find I is equal to 2.3 times 10 power of negative 3 kg meter squared. Okay, so kg meter squared. Okay, make sure tulis unit yang betul. Ni salah ni kat sini ni. Okay, unit kat sini salah ni. Awak jangan tengok yang ni. Okay, alright. So 2.3 times 10 power of negative 3 kg meter squared. So this is the answer. Okay, so finish example number 2. So let's proceed to example number 3.